Hello everyone, this is a quick tutorial on how to get PicoDuck running on your Raspberry Pi Pico. This is gonna be split in two parts. First I'm gonna do a Linux installation tutorial, and secondly I'm gonna do one for Windows. In both of those I will show both how to get it from releases and how to build it from source. So I guess I'll get started with Linux because that's what I'm on right now. For Windows I'm gonna do it in a virtual machine because I don't have it installed in bare metal as is yet. So first I'm gonna show you how to get it from releases. So just go into here and download the UF2 file that you'll find here on the releases. There we go, so it's downloaded, and now what you want to do is plug in your Raspberry Pi Pico and make sure you hold the boot select button, and you can see that it is now mounted. So I'm gonna copy the file over to the Raspberry Pi, which should show up as a newly mounted device. Okay? And after it's copied, it will disappear, and yeah, that's the installation for the releases version. Now, if you want to install it from source, you need to get the Arduino IDE. Either 2.2 or 1.89 should be fine, but there are going to be some minor differences on how you're going to do that. So I think I'm going to grab the zip file. Just download if you don't want to donate. I would recommend to do. Now that it's downloaded, we can extract it. So I'm gonna do this by command line because that's the way I prefer to do things. So then there you go. Now I can go into Arduino IDE. And there should be a couple of files here. We just need to run Arduino IDE just like this. And you'll see it just starts. So I'm gonna move this here. Great. What you need to do now is to get the source code for the PicoDuck. How you can do that is either using this command that is given to you right here, or by downloading the zip. I'll just download the zip because I assume most of you don't use Git, so I'm gonna just extract that here. As you can see, it's downloaded, and let me move this actually somewhere else. Cool. So I'm gonna go to downloads and extract it, just like this. And let me move it to some place more sensible. So PicoDuck. There we go, just like that. So just copy this link over here, go into Arduino IDE, and then go to File, Preferences, and then just paste it where it says Additional Board Manager's URL. So just paste it in and click OK. Nice. Now I want to click on this icon, Boards Manager. For the 1.8, it should be in Tools, Board, and then Boards Manager. So then you want to search for the Pico, and there you go. Here it is. So by Early F. Philhofer, I think I pronounced that correctly. If I don't, just let me know in the comments. So you're just gonna click on this install button and just wait. Great, so it seems to have been installed. Now we're gonna go and install the required library, which is SPI Flash. We're just gonna go to Sketch, Include Library, Manage Libraries, or press here if you're using 2.0, and type in SPI Flash. And you should see Adafruit SPI Flash. So you wanna click on installing this as well, and install all. So now we can finally open our project. So click on File, Open, and I'm gonna go to where I've put it. There we go. Open the .ino file. Then I can close this window as well. A bunch of stuff opened, you don't need to worry about it. So what you need to do is find this file called config.h. So just go in there, and this is gonna contain the configuration for your Raspberry Pi Pico. So I'll quickly walk through this. So these are just LED pins. You don't need the external LED pin to be hooked up to anything. It's optional. You don't need to change this either. And this is the hold pin. So if high, you'll suspend the current execution of any program, right? So you can, if you accidentally start a program, you can press this pin and you just stop where it is. There is this MSD pin, MSD standing for mass storage device, and if high, it will allow you to just put files into the Raspberry Pi. So there'll be like 0.lua, 1.lua, your program files. Now there is this define here. What this is for is if you don't want to put a pin for this, you can instead use program index 15, which is this in binary, instead to put a device into mass storage mode. So you can just remove this comment over here, and now it'll use the program index to know whether or not to enable mass storage device. And these pins are the ones that are responsible for selecting the currently running program. As I said, you can change those, but basically these indicate in binary which program to run. So pin B0 would be 1, pin B1 is going to be 2, B2 is going to be 4, B3 is going to be 8, right? And you can calculate the index pretty easily by just adding those. So let's say, I don't know, you want to run program number 5. So you want to turn on pin B2 and B0 because 4 plus 1 is 5, so there we go. There is also an initial delay programmed into it. This is because some operating systems might detect typing from the start and will just refuse to accept the USB device. So you can uncomment this if you wish to disable that feature, but I would not really recommend it. But if you know what you're doing, you can, of course. And this is the initial delay that I was talking about here. So now that that's covered, you want to select your board. So I want to go here and search for Raspberry Pi Pico, right? And you can choose PicoW if you have that. So just click OK. You can also go here, select board and Raspberry Pi Pico, and select it from here. Oh, and that should give you the Raspberry Pi Pico board, which is going to give you a bunch of options here in tools. So you don't need to worry about most of those. The only things you need to change are the USB stack from Pico SDK to Adafruit Tiny USB. Okay, quick interruption here. You need to, what I forgot to tell you in the tutorial is to go to Tools and select the flash size to include this FS thing. So this is the reason why it may not work for you when you plug it in to your computer using in MSD mode. So just be sure to select this in the flash size. So yeah, just select it here and that should be good. And I think that should be pretty much it. Yeah. Okay, so once you got that done, you want to plug in your Raspberry Pi Pico again in boot Selmo, yeah, whatever it's called. Okay, so going to tools, port, it should show up as UF2 board. So just click on that and press the upload button. You should compile the sketch and upload it to the Raspberry Pi Pico, which will just give you the program. You see a bunch of warnings and stuff, don't worry about it, it's fine. Okay, there you go, it is done. So, let me type program 15. Okay, I have a couple of deep switches, so that makes it quite easy to do. And if I insert it, as you can see, it has appeared. So that's good. So now, onto Windows. Okay, so now I'm gonna be installing this on the Windows. I'm using a virtual machine, as you can see here. This is because I don't have a Windows installation on this machine, so I just decided to create a virtual one. So first of all, we're gonna insert our USB stick into the virtual machine, or real computer in your case probably. And there we go. So this is gonna say a bunch of stuff. Okay, so you wanna go to initial release and download this UF2 file. There we go. After that, you're gonna just drag and drop it into your Raspberry Pi device here. Okay, there you go. So now the program is now uploaded, and that's that. Now, if you want to compile this from source, you're gonna have to use the Arduino IDE. So go here, download either 2.2 or you can use the legacy one. I'm gonna use 2.2 because it's newer. I don't know if it's any better, but yeah, I'm just download the installer. Okay, so that seems to be stuck, so I'll just try the other download option. Maybe this one will work. Maybe, I hope. Okay, it's installed, so just press finish. Alrighty, you should see the Arduino IDE open up. Great. So now I'll just put this to the side, please. Okay, I guess I'm not doing it because he does not like me. Oh wait, I should probably whatever. It's fine. It's fine. Okay. So now we need to go here into the README, and I've given you a link. So just copy that link and go to File, Preferences, and where it says Additional Board Manager URLs, just paste it there and press OK. Cool. Now wait for that to download and go inside Tools, Board Manager. Great. And we're looking for the Pico, the Raspberry Pi Pico. Here it is by Earl F. Philhauer. Sorry if I pronounced that wrong. And press install. Okay, so it seems to be installed. Now, we're also gonna need this Adafruit SPI flash thing, so just look it up. Okay, no, not here. In the so you need to go to Sketch, include no, oh my gosh, include libraries and manage libraries. So just search there instead. Don't be bad at navigation like me. So just click install and install all. Okay, great. So it's installed, and that's pretty much it. Now we're just gonna get the source code to this. So go to the code. You could either just use git clone if you know how to do that, or just download the zip. There you go. So I'm gonna just quickly open this and put it on the desktop, because why not? Alrighty, so file, open, desktop, and there you go. Sure, click OK, and I can close this previous window. Alright, so this is pretty much the project. Interestingly enough, it doesn't seem to have loaded fully, which I'm gonna just rename this to PicoDuck, just PicoDuck, like that. Oh, what? That is weird. Okay, so just rename this to PicoDuck, and there should. Oh my goodness. Okay, don't press OK on that. Just rename the folder and just open it. The INO file. In the IDE itself, you can go to File, Open, and select it from there. Okay. So this is gonna load a bunch of files up, which is what we want. So we want to go to config, and this is where you can configure your PicoDuck. So these are just some LED pins you can use for debugging or anything like that. There's also an external LED pin. You don't need to use it, but I would personally use it for debugging purposes, because the built-in LED pin is going to be used to indicate like errors. So yeah, I just prefer to have a separate LED. So there's that. There is this hold pin, which if it's powered, you'll suspend the program execution. So if you insert your PicoDuck and you have like something that you don't want to run it, you can just press this and you'll suspend the execution while pressed. So yeah, this is what the hold pin does. There's this MSD pin, MSD standing for mass storage device. So if this is enabled, then the PicoDuck will allow you to just put files on it, Lua files. So yeah, you can use this. Now there's this comment without define. What this does is, if you uncomment this, right, this will no longer use the MSD pin, so this is going to be practically ignored completely. And this is useful if you don't want to put like another switch for this or another button. And you'll use, but as a trade-off, you'll use the last program index, which is 15. So yeah, this is just a trade-off that you may or may not be willing to make. So yeah, that just depends on you, on what's your situation with how you want this to be set up. So there's also these pin definitions. These are for specifying the program index in binary. So the first one will be 1, the second will be 2, the third will be 4, and the fourth will be 8. And you can quite easily convert back to base 10 by just adding like 1 plus 4 plus 8, right? And there is also this define here, which just removes the initial delay for typing and mouse movement. This is to prevent operating systems from blocking the input. Now you can uncomment this, which will remove the delay, and your code may not work on some systems because they might have recent software like antivirus or something like that that might just block it completely. So I'll leave this commented. Now there is this typing delay, and this is the delay I've been talking about up here, and you can just modify it in milliseconds. So that's pretty much the whole config file covered, and now you just want to upload this to the board. So go to Tools and select Board, Raspberry Pi Pico RP2040, and go and select the first option, which should be Raspberry Pi Pico. Nice. After that, go to Tools, and there is a USB stack option now, and just select Add a full-time USB because Pico SDK is not good enough for what this is. I mean, it's good for most things, but we're gonna use Add a full-time USB because we're doing more advanced stuff. Okay, so now this should be able to build. Okay, quick interruption here. You need to, what I forgot to tell you in the tutorial is to go to Tools and select the flash size to include this FS thing. So this is the reason why it may not work for you when you plug it in to your computer using in MSD mode. So just be sure to select this in the flash size. So yeah, just select it here and that should be good. So just put your Raspberry Pi Pico while holding the boot cell button into your computer. There you go. So then you can just press upload. So this is going to compile the sketch and upload it. So this may take a while depending on your machine, but once that's done, I'll get back to you. Now you may see some errors pop up here. Well, those are not really errors, those are warnings, so you can safely ignore those. Everything is going fine, just fine. Okay. So we're gonna get upload errors here. Oh right, I forgot to specify the port. So once you plug it in, go into Tools, Port, and you don't want to select any serial port unless you're gonna use the debug port, but whatever. Just select UF2 port because this is what we want. So I'm gonna just upload again. Alrighty, it's done, and there you go. It just uploaded. That's nice. Okay, cool. So now that is freaking out. Okay. Alrighty. So I had to reboot my computer, but now if you enter MSD mode using either the pin or the program index of 15, a new device should appear called PicoDuck. So you can just go over there, and you're gonna see I already have some files in here. Let me just delete those. Okay. So this is how it should pretty much look like to you. So there should only be like at least at most one file called system volume information. But that should be pretty much it. Okay, so scripting. Let me open the website. So scripting is done through Lua, and the reason why I chose Lua is because it's relatively easy to use and learn, and it's pretty powerful for what it is. And because the rubber ducky uses like its own custom script, which I find pretty weird, so I just wanted to use Lua. So there are a couple of instructions that you can do. What I want to do right now is to just give this make this just type hello world, right? So I'll just create a new file called 0.lua in the root of the PicoDuck. So what I'm gonna put here is just a simple instruction: type ln hello world, just like that. After you type this, you can just save it, right? And you should save on your Raspberry Pi Pico. So then you just can unplug it, right? And I'm gonna put it into the first program. So the first program is selected. I'm gonna replug it in. So now it should start automatically typing hello world. So well, this is awkward. I selected the wrong program. Okay, now I should start typing. This is the hold on? I think it is. Yeah, okay, there we go. It started typing. So my hold pin was on, so that's why it wasn't working. But as you can see, it works. It can type. Let's make it move the mouse now. So I'm gonna just plug it back in. Give me a moment. Alrighty, so that is not good. Okay, there we go. So this is pretty much the whole program we have so far. Let's make it move the mouse, shall we? So let's just wait like 200 milliseconds, and then mouse move, and it's gonna take an X coordinate, a Y coordinate, and the amount of scroll we want. So I'm just, well, it's a scroll is option. So I'll just give it I don't know, move it 20, 20, and then just do this a couple of times. Actually, that is not a nice way to do it. So for I is 1 to, let's say 10, do, and let's use Lua, if you have it installed. Right, come on. Okay, there we go. So now I'm gonna replug this in, and you should see the mouse moving. If it doesn't, that is not nice. Love it. Okay, as you can see, the mouse is moving. Very nice. I don't know if you catched it, but I'm gonna do it again. And there you go. It just moves. Nice. We can also, there's also a bunch of stuff that we can do here. We can even interact with the hardware if we have anything wild and we want to do anything special with that. There is also some instructions for LEDs. There is this blink LED instruction, which will blink the LED, the built-in LED, at a specified rate in milliseconds. So yeah, you'll just turn it off, wait that rate, turn it back on, wait that rate, and so on and so forth infinitely. So that's what that does. As for the mouse, we can move it as we've seen. I should probably update to include a scroll, but whatever. There's this mouse click, mouse press, and mouse release, in which you can specify a mouse button. I forgot to create a struct for this. I'm gonna patch this before releasing this video, so you should be able to do like mouse left, mouse right, and mouse middle. I may add some more, and that's what you would put inside here. That's the mouse button. It's really just a number from Arduino.h if you want to look into that, but yeah, I'm just gonna add mouse left, mouse right, and mouse middle. I just forgot to do so. And so now this is the keyboard. So there's this set speed, which says the speed at which the key is pressed. And this is in keys per second. So it will type the key, wait a specified amount, and then type again. Alright, so this these are pretty special. Those just save typing you a bit some unnecessary keystrokes. So these are 3 functions: GUI, Alt, and Control. And what these do is they press the respective key together with a key you specify. So you can use something like GUI GUI R, and that would bring up the run prompt. You can also use stuff like Win and Meta. For these, they have aliases if you want to use those, if you're more used to the traditional ducky script. There's write, which just types a single key. There's press, which presses it, and there's release, which releases a key, and if you don't specify a key, you release all keys. So that's that. There's also type and type ln. So type is just types what a string you give it, right? But type ln is gonna press carriage return at the end. So yeah. There's also wait, which you have also sleep and delay as aliases for it, and this just waits a specified amount of milliseconds. So that's that. There's also the LED status codes if you want to look into that. So yeah, that's pretty much all you need to know about this. You can just create multiple programs if you want to. Oh, I have not plugged my PicoDuck in. One moment. Alright, so you can have multiple programs. You just need to specify the index and then .lua. So you can do 1.lua, 2.lua, etc. Right, all the way up to 15.lua. So yeah, this is how I use this thing, and hope you have fun with it, I guess. But don't use it for any illegal things. I do not condone that in any way. Just use this for, I don't know, pranks, or maybe you want to set up systems fast, which is what I use it for. Yeah, just don't do bad things. No, just don't. If you do, then that's your own fault. Yeah, just have fun, and hope this video was useful to you. And yeah, that's it. See ya.